Elon Musk isn't afraid to spend money on the most advanced technologies for Tesla's factories, with one condition: they must be truly useful. And the Giga Press is the most useful machine Musk has ever brought to Tesla, even though it's not cheap. Tesla's success today is undoubtedly partly thanks to the Giga Press, the game changer that allows Tesla to produce a car in seconds. But that's just the 6,000 tons and 9,000 tons models. The 50,000-ton Giga Press will be even more shocking, capable of producing 12 cars in just 60 seconds. Elon Musk has confirmed and believes that new car models will be placed into this machine, and the production line will be so crazy that no one will be able to get close. So, how does the Giga Press produce 12 cars per minute? Is this the solution for the next generation of cars? Let's explore right now. You might not know this, but the story of Elon Musk and the Tesla Giga Press is quite thrilling. Bringing this machine to the company was no easy feat. According to what we know, the idea for the Giga Press came from an inspiring moment for Elon Musk. Musk once held a die-cast toy car on his desk and asked himself, why can't we do the same with real cars? He realized that casting large parts, like the entire underbody of the Model Y, could significantly reduce weight, cost, and assembly time. At that time, Tesla was under immense pressure to increase the production of the best-selling Model Y, and the company needed to find ways to reduce costs more effectively. The Giga Press was seen as the key to achieving this goal, as it helped reduce the cost of manufacturing the vehicle frame by 20 to 40%. However, building a machine like this had never been done before in the automotive industry, and die-casting manufacturers initially doubted its feasibility. At that point, the automotive industry typically used steel stamping and robot welding to create car frames, which required hundreds of parts and complex processes. Despite the machine's potential, Elon Musk reached out to 6 major die-casting manufacturers to inquire about such a press. Surprisingly, 5 of them declined, considering the idea too crazy and unfeasible. It seemed that hope was lost, but luckily, in the final contact, Idra, an Italian company specializing in die casting, accepted the challenge. Of course, even Idra wasn't entirely sure, and they only said maybe. For Musk, that maybe was a huge deal at the time. To quickly bring the Giga Press to life, Tesla worked closely with Idra for over a year to develop it. The process was far from easy. Tesla continuously requested design modifications, forcing Idra to adjust the machine to meet the requirements. A representative from Idra shared that each time Tesla proposed a change, their engineering team had to work tirelessly to update the design. And in the end, the Giga Press was successful. Tesla started with the 6,000-ton Giga Press to produce the rear chassis of the Model Y, followed by the 9,000-ton machine specifically for manufacturing the Cybertruck. Now, Elon Musk is moving forward with the 50,000-ton Giga Press, dedicated to the chassis of the Cybercab and the affordable Model 2. Compared to the 6,000-ton and 9,000-ton Giga Presses, this machine is far more efficient, as it can cast multiple frames at once, and the casting time has been reduced from 70 seconds to just 5 seconds. Yeah, it sounds unbelievable. We didn't believe it either, but it's the truth.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa, like real fast. And then I guess maybe we need to just get even bigger casting machines. Sure, why not? Let's 50,000 tons.
Okay, so how massive is this machine? How long does it take to assemble? How is it different from the 6,000-ton or 9,000-ton Giga Press? And how can it produce one Cybercab every 5 seconds, 12 cars per minute? These are exactly the questions that popped into our heads when Elon Musk mentioned the 50,000-ton Giga Press. Many people still mistakenly think that the 50,000 tons refers to the weight of the machine, but that's completely wrong. The 6,000 tons, 9,000 tons, or 50,000 tons refers to the pressure the machine generates, not its mass. However, its size is still enormous, and its weight could reach over 3,000 tons or 6.6 million pounds. To put it in perspective, as far as we know, the 6,000-ton Giga Press weighs about 430 tons or 948,000 pounds, while the 9,000-ton version weighs about 688 tons, or 1.52 million pounds. This means that the 50,000-ton version could weigh up to 8.16 million pounds. Yeah, a real beast. Compared to the current Giga Press models, this new machine generates about 8.3 times the pressure of the 6,000-ton version and 5.5 times that of the 9,000-ton version. So, just the installation process could take months. In terms of size, the 50,000-ton Giga Press is 131 feet long, 42 feet wide, and 39 feet tall, equivalent to a 4-story building lying on its side. Sounds shocking, right? Clearly, Tesla had to build a special facility just to house this machine, with a reinforced concrete foundation several meters deep to support its insane weight. If you doubt it, you should know that the 6,000-ton Giga Press alone is 64 feet long, 19.69 feet wide, and 17.39 feet tall. So, the 50,000-ton Giga Press will be many times larger. But how does the 50,000-ton Giga Press work? The Giga Press applies ultra-high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving no defects. Once cast, the part is evenly cooled, causing the aluminum alloy to harden into its final shape. This process requires extreme precision. If it's too fast, air bubbles can form. Too slow, and the aluminum starts cooling before fully filling the mold. The cooling process is carefully controlled through a uniform cooling system, which helps the final product achieve high strength and accuracy. After cooling, a robot extracts the part from the mold, trims off any excess material, and sends it through a quality inspection process. The Giga Press plays a crucial role in reducing vehicle weight, increasing structural rigidity, and boosting performance by casting a single large component instead of welding together dozens of smaller parts, saving both time and labor. Today, there are various types of gigacasting technology from multiple suppliers on the market. Aside from Tesla, companies like General Motors, Hyundai, Volvo, Zeekr, and XPeng have also invested in this tech. Notably, XPeng has invested in a 16,000-ton Giga casting machine. The operating mechanism of the 50,000-ton Giga Press isn't entirely different from that of the 6,000 or 9,000-ton models. First, the process still begins with preparing the materials. Tesla will melt down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 degrees Celsius. Then, any surface impurities are removed before the molten metal is transferred via heated pipelines to another sealed furnace, which maintains a temperature between 750 degrees Celsius and 850 degrees Celsius. From what we know, the Giga Press uses a 2-furnace system to process the aluminum alloy. One acts as a melting furnace, powered by natural gas and operating at around 850 degrees Celsius. The other stores the molten metal and is electrically heated, maintaining a temperature between 750 degrees Celsius and 850 degrees Celsius, as mentioned earlier. The empty space inside the holding furnace is filled with nitrogen gas, which helps prevent the formation of oxides in the molten aluminum. It also helps maintain a consistent temperature. Additionally, operators use argon gas, a rotary degasser, and a silicon carbide filter to remove further impurities and particles larger than 25 microns. That covers the material preparation stage. Next up, mold preparation. Before each cycle begins, the Giga Press lubricates the mold surface. A robot sprays around 35 milliliters of soybean oil in a thin, even layer across the mold, kind of like greasing a baking pan, to make it easier to release the part afterward. Then the system creates a vacuum to remove any air, and the molten aluminum is transferred from the holding furnace into the Giga Press's shot chamber. There, the molten metal is injected into the mold cavity by a high-speed piston. That piston is also lubricated with about 8 milliliters of oil before each shot.
In a single casting machine, we could do like 5 at a time or something, you know? I'm trying to think, like, how do you scale castings? Because you got liquid metal, metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
After the aluminum is injected, it's left inside the mold until it solidifies. The casting is ejected from the mold at around 400 degrees Celsius. Then, The raw casting is placed into a cooling bath to quickly bring the temperature down from 400 degrees Celsius to about 50 degrees Celsius. This rapid cooling helps eliminate certain defects and enhances some of the material properties. Finally, the opened mold is cooled down to around 185 degrees Celsius and thoroughly cleaned by a robot to prepare for the next cycle. The next casting cycle typically begins about 1 to 2 minutes after the current one finishes. Any excess metal is trimmed off and recycled for the next melt. The final product is X-rayed to ensure quality and structural integrity. One of the biggest challenges during the casting process is keeping the mold from bursting open under the intense pressure of molten aluminum injection. That's why the machine must apply extremely strong clamping force to hold the mold tightly shut. And with the 50,000-ton Giga Press, that clamping force is absolutely massive.
So I mean, we got to jam the liquid metal in, cool it down real fast, like real fast.
According to Elon Musk, to make this all possible, Tesla had to design an ultra-fast cooling system, a smart mold release mechanism, and an AI-powered automated quality inspection process, a combination of technologies that no other automaker has ever attempted to implement at this scale. This also marks the first time the auto industry is shifting toward a production model that closely resembles electronics manufacturing: fast, streamlined, and with extremely optimized use of space. With the new one-piece casting process, car production has become much simpler. Tesla's productivity has doubled, and costs have dropped significantly. The production line, which used to require 1,000 robots, now only needs 300. We believe that the 50,000-ton Giga Press will bring about a huge revolution for Tesla's new vehicles. Manufacturing them will be faster and much less complicated. In fact, the idea of using the Giga Press was ridiculed by the automotive community. Many believed the technology was impractical, especially since aluminum molds wear out faster than steel stamping dies, potentially increasing long-term costs. However, Musk and Tesla have proven the opposite. It's no coincidence that Ford, Hyundai, Toyota, GM, and Volkswagen have also spent money to buy the Giga Press, all recognizing how much Tesla benefits from this machine. Producing 12 cars per minute or 720 cars per hour completely changes the way cars are made, something no competitor has been able to achieve. This is perfectly aligned with the Model 2, as Elon Musk confirmed that this car will have a massive production volume, surpassing the combined total of Model Y and Model 3. Switching to some other recent updates, Waymo has recently suspended its autonomous taxi services in certain areas of Los Angeles and San Francisco due to ongoing violent protests. The protests erupted in Los Angeles and San Francisco against the Trump administration's immigrant crackdowns. The most alarming incident occurred recently when several Waymo robotaxis were severely vandalized, with at least 5 cars caught in the line of fire, and at least 1 car was completely burned. When these cars caught fire, toxic smoke from the lithium-ion batteries was emitted, which could affect health, prompting the police to advise people to avoid the downtown area. The cost of these attacks is notable. Each Waymo robotaxi is valued at between $150,000 and $200,000, according to a 2024 report from the Wall Street Journal. Switching to other news, the Tesla robotaxi service is getting very close, and we will soon see autonomous vehicles operating on the streets of Austin. A recent video posted on X has provided the first glimpse of Tesla's robotaxi, which is expected to be deployed in Austin, Texas, this month, with a major event scheduled for the 12th. It's clear from the short clip that Tesla's robotaxi operates completely without a driver. We believe that Tesla is achieving extremely high reliability for its robotaxi service, and it's quite exciting to think about next month when Tesla will allow more customers to test them instead of the limited number this month. What do you think about the future of these self-driving vehicles? In other news, the Tesla Model Y has solidified its position as the best-selling SUV in China for May, with 24,770 vehicles registered. It surpassed competitors like the BYD Song Plus, with 24,240 registrations, and Geely's gas-powered Xingyu L, which ranked third with 21,014 registrations. Although Tesla's Q1 profit dropped by 71%, which led many to believe that very few Model Ys were sold, We were mistaken. In the first 5 months of 2025, Tesla sold 126,643 Model Y units in China, surpassing the BYD Song Plus with 110,551 units and the BYD Song Pro with 80,245 units. This is quite an impressive number, especially considering the Tesla Model Y remains a premium vehicle, much more expensive than many of its competitors. Although the Model Y is the champion SUV, Tesla's year-over-year performance in China is still facing some challenges. Total sales for May were 38,588 vehicles, a 30% decrease compared to the same period last year. From January to May, Tesla delivered 201,926 vehicles in China, a decrease of 7.8% compared to the same period last year. However, these declines were significantly impacted by the company's transition to the new Model Y in the first quarter. Hopefully, things will be stronger in quarter 3 and quarter 4. What Tesla is doing with the Cybercab isn't just about building a car without a steering wheel or pedals. It's about reinventing how cars are made. It's not just about redesigning the vehicle, but reimagining the entire production process. Instead of a traditional assembly line, it becomes a network. Instead of human workers, it's robots. Instead of hand-assembled parts, it's stacking pre-made modules together like Lego bricks or toy blocks, just like Elon Musk said.
And that's actually kind of how they do it in like small volume castings. They'll have a casting block that'll make 100 Matchbox cars at a time. Maybe we just make that real big. Yeah, we have the cathedral of casting back there.
Yeah, Elon Musk actually compared producing the Cybercab to making toys. The only difference is that Tesla is scaling up the machine to build as many vehicles as possible. Once the Giga Press finishes casting 5 Cybercab chassis, they're immediately fed into the unbox process line, a system so fast that, as we mentioned earlier, humans can't even approach it safely. This machine can cast 5 car bodies simultaneously, which means the mold is significantly larger, and the casting process becomes far more complex. The metal has to travel longer distances within the mold, increasing the risk of defects. As highlighted earlier, if the injection happens too fast, it can trap air bubbles, weakening the structure. But if it's too slow, the aluminum may begin to solidify before the mold is fully filled. All of this takes place inside a 50,000-ton machine. So naturally, Tesla needs time to transport, install, and fine-tune the Giga Press before it can go live. Recognizing the leap Tesla has made with this efficient production model, many automakers, like Toyota, General Motors, Geely, Volvo, and Hyundai, are now trying to follow suit. However, most are still only starting with 6,000-ton Giga Press machines. So if Tesla already has a 50,000-ton Giga Press up and running, when will the others be able to catch up? If you could own an EV that drives nearly 1,000 miles on a single charge, retains almost all of its battery capacity after 3 years, performs reliably in a wide range of temperatures, recharges in just 10 minutes, and costs about the same as an ICE car, how could you say no to that? Yeah, let's be real, it sounds like something out of a sci-fi movie, right? Because in today's world, even hitting a 500-mile range is still a tough challenge that many EV automakers, including Tesla, haven't fully cracked yet. However, we're willing to bet that's about to change. A revolutionary new battery is heading into mass production, one that could be a true game changer for EV range. Elon Musk might soon bring it to Tesla because if he doesn't, the company could face a major setback. At least 3 other automakers have already poured serious investment into this technology. You might not believe it. We didn't at first either. But the truth is undeniable. Yes, we're talking about solid-state batteries, the most powerful battery technology the world has ever seen. So what makes them such a breakthrough? And why do they pose a serious threat to Tesla's 4680 battery? While we've touched on this battery in earlier episodes, many people still don't fully understand what solid-state batteries really are. So here's a simplified explanation. All batteries in the world share 4 basic components: an anode, a cathode, a polymer separator, and a liquid electrolyte. And it's the electrolyte that we need to focus on here. Solid-state batteries also have those same 4 components, but the key difference, the real game changer that's earning them so much attention, is the switch from a liquid electrolyte to a solid-state electrolyte. So, why are automakers racing towards solid-state batteries? Market research firms predict that EVs will eventually replace ICE cars and become the dominant force in the automotive industry. And to take the undisputed lead in that future, EVs need to match the driving range of today's gas-powered cars. That means boosting battery capacity significantly. Now there are two main ways to increase the power of an EV battery pack. The first is to simply make the pack bigger, go from 60 kilowatt hours to 75 kilowatt hours or more. But what's the trade-off? Increasing battery size means higher costs, more individual battery cells, extra weight, and more space taken up inside the vehicle. Sure, it sounds straightforward, but it's far from ideal. So what about developing a new type of battery, one that's more powerful, safer, and faster to charge? That seems like a better direction, but it's not exactly easy. Lithium-ion batteries have been gradually improved over the years, but they've hit a wall, especially in terms of safety, mainly because of their chemical makeup. You see, modern lithium-ion batteries use a liquid electrolyte, which makes them vulnerable to damage. They can swell due to temperature changes or even leak or catch fire if there's a hard impact. These safety risks have pushed automakers to seek better solutions. That's why manufacturers are now trying to replace liquid electrolytes with solid-state ones to overcome the long-standing limitations of traditional lithium batteries. And this difference is a big deal. It's what could finally unlock a new level of safety and performance in electric vehicles. Of course, we admit that solid-state batteries aren't some brand new invention. Their potential was discovered years ago. In fact, Toyota is often seen as the pioneer in the effort to bring solid-state batteries into the real world. What's worth noting is that Toyota is confidently aiming to reclaim the ground it lost to Tesla and BYD, seeing solid-state batteries as the key weapon to elevate their EVs to a whole new level. Now, whether or not Toyota will actually succeed is up for debate, but there are growing signs that Tesla could be facing real competition. Right now, even Tesla's most advanced 4680 battery only gives the Cybertruck long range a range of 354 miles with a massive 123 kilowatt-hour battery pack. Sure, Elon Musk has said that 300 miles is enough for daily driving, and that may be true. But in our view, EVs will never truly break through unless they can consistently exceed 400 miles of range. Without that, it's tough to compete or convince drivers to make the leap from gas-powered cars to electric. That's why Toyota's claim that its upcoming EVs could travel up to 745 miles on a single charge is such a big deal. That's not just impressive, it's a game-changing number. It beats many gasoline vehicles in range, while offering the cost savings of electricity over fuel. The Japanese auto giant says their EVs will be insane once they're powered by solid-state batteries. So what exactly are the advantages of solid-state batteries? Over the past decade, EV batteries have become significantly more efficient. Back in 2015, a typical EV battery had an energy density of around 150 watt-hours per kilogram. Today, some of the best lithium-ion batteries have reached 300 watt-hours per kilogram or more. Solid-state batteries stand out because they're much lighter and offer far higher energy density than traditional lithium batteries. With energy densities exceeding 500 watt-hours per kilogram, they blow past the 250 watt-hours per kilogram average of conventional lithium-ion batteries, allowing much more energy to be stored in the same weight. That's a huge deal for electric vehicles, where both weight and efficiency are critical. Instead of the liquid electrolyte and separator used in traditional lithium-ion batteries, solid-state batteries use solid materials, like solid oxides or sulfides, as their conductive electrolyte. This solid material is denser than liquid or gel-based electrolytes, enabling solid-state batteries to generate more energy per unit of weight or volume. Another benefit of Toyota's high-energy density batteries is that they'll reduce how often you need to charge your car. Fewer charges mean saving both time and money. Thanks to their higher energy density, solid-state batteries allow Toyota to boost both the power and performance of their EVs. That's because these batteries can deliver higher voltage and current, improving acceleration, handling, and top speed. Now imagine this type of battery paired with Tesla's 48-volt electrical architecture. It's an exciting possibility. It's clear that 745 miles already beats the reigning range king, the Lucid Air. But Toyota isn't stopping there. Their second-generation, solid-state battery tech is pushing the boundaries even further, promising a driving range of up to 932 miles. That's nearly 1,000 miles on a single charge, more than 3 times the range of most popular EVs today. Honestly, this kind of claim would usually raise eyebrows, especially coming from Toyota, a company known for making bold promises that don't always materialize. But we can't ignore the potential this time, and here's why. Toyota currently holds over 8,274 patents related to solid-state battery technology. That level of commitment and innovation suggests they're truly serious about making this happen, not just hyping it up like before. And it's not just Toyota making progress. Other companies have hit solid-state milestones too. Samsung recently unveiled a solid-state battery with a range exceeding 600 miles and the ability to charge up to 80% in under 10 minutes, boasting an energy density of 500 watt-hours per kilogram. Factorial and Mercedes claim their solid-state batteries can offer over 600 miles of total range, while also cutting battery weight by 40% and reducing size by 33%. QuantumScape, another frontrunner in the space, has developed lithium metal solid-state batteries that also show strong potential to reach 500 watt-hours per kilogram energy density. Thanks to the use of advanced materials, solid-state batteries deliver a dramatic boost in energy density, something even Toyota openly acknowledges. While traditional lithium-ion batteries typically use metal lithium in the anode and graphite or silicon in the cathode, solid-state batteries open the door to higher capacity materials. The anode can now be made from high-voltage compounds, while the cathode might feature lithium-rich manganese or silicon-carbon blends. Yeah, it's easy to see why solid-state batteries offer a level of energy density that conventional lithium batteries simply haven't reached in years. But let's be real. High energy density alone isn't enough. If it takes hours to fully charge, no one's going to be impressed. So how fast can solid-state batteries charge? Clearly, we've all seen that EV charging times have been shrinking over the past few years. It used to take hours to fully charge an EV just to get around 200 miles of range. But now, thanks to advancements in battery tech and charging stations, we're talking about minutes. On average, it takes about 35 minutes to fully charge an EV at Tesla Supercharger. However, compared to the few minutes it takes to refuel an ICE car, 35 minutes still feels pretty long. That's why many customers remain hesitant about EVs. They're worried about running out of battery mid-trip and struggling to find a charging station. Most people simply don't like waiting 30 minutes at a charging stop. With Tesla's superchargers, you can charge a 2170 battery pack up to 80% in about 35 to 40 minutes. The newer 4680 battery cuts that down to roughly 30 minutes for a 10% to 80% charge. But solid-state batteries aim to be even faster. QuantumScape's solid-state battery tech, for example, can reportedly charge up to 80% in just 15 minutes, thanks to its ultra-fast ceramic separators. Sounds quick? Toyota has made an even bolder claim, saying their solid-state batteries will be able to charge from 0 to 100% in just 10 minutes, with potential charging speeds of 10C or more. That means you could take a 10-minute power nap in your car and be ready to drive nearly 1,000 miles. Sounds unbelievable, right? But ultra-fast EV charging in just 10 minutes is already being tested. CATL, a key Tesla partner, has released 2 super-fast charging battery types, Shanxing and Shanxing Plus, both tested to fully charge in just 10 minutes. Solid-state batteries use metal oxides, metal sulfides, or solid polymers as electrolytes, and the softness of sulfur is a key factor that helps ions move more easily. In the case of oxide-based electrolytes, they can handle higher voltages, meaning more ions can be pushed through the electrolyte. Some studies suggest that solid-state batteries can be charged and discharged over 5 times more cycles than traditional lithium-ion batteries, significantly extending their lifespan. It's important to note that liquid electrolytes in conventional lithium batteries can be negatively affected by high temperatures. In contrast, The solid electrolytes in Toyota's solid-state batteries actually perform better under heat. Since fast charging generates a lot of heat, this feature ensures strong performance during rapid charging sessions. So, are solid-state batteries safer than regular lithium batteries? Thermal runaway and EV fires have become major concerns for customers, battery designers, and automakers. While such incidents are rare, they can be very serious, because as you may know, lithium fires burn for a long time and release extremely toxic smoke. That's why safety is a key question for any battery technology. Lithium-ion battery fires are uncommon, and most automakers already include protective casings and safety measures to prevent them. But when these fires do occur, they can be intense and very hard to extinguish, sometimes requiring thousands of gallons of water. That's one reason why many EV skeptics liken driving an electric car to sitting on a ticking time bomb. At first glance, simply switching from a liquid to a solid electrolyte already shows that solid-state batteries offer clear safety advantages. They eliminate the flammable liquid electrolyte and replace it with a non-flammable solid one. Solid electrolytes also typically operate across a wider temperature range, helping reduce the risk of thermal runaway caused by overheating cells. Even heat generated from external sources is often less of a concern with solid-state designs. Tests like puncturing, slicing, or fast-charging solid-state batteries have been conducted, and in most cases the results show they don't catch fire or explode. Solid-state batteries are significantly safer than lithium-ion batteries, especially in situations involving overcharging, mechanical damage, or external short circuits. This makes them very attractive for use in EVs and other applications where safety is critical. That said, they're not completely foolproof. Solid-state batteries still need further improvements to fully eliminate the risk of thermal runaway under extreme conditions, like temperatures above 300 degrees Celsius or internal short circuits caused by manufacturing defects. But, even so, they pose far less risk than current battery technologies, and creating electric vehicles that don't catch fire is a massive win for drivers, nearby residents, and firefighters alike. Many EVs today are only expected to last a few years, while people typically expect their cars to run for a decade or longer, sometimes even several decades. Now, we can't make promises yet since there's been no long-term testing of EVs using solid-state batteries. But based on all the advantages we've listed so far, we believe it's reasonable to expect better durability than current lithium-ion packs. So yes, solid-state batteries offer high energy density, fast charging, and better safety. It sounds like the ultimate battery, right? But with so many advantages, a big question naturally comes to mind. Why aren't these batteries already mainstream? What's stopping them from hitting the mass market? And more specifically, if Toyota says it'll have solid-state batteries by 2027, why the delay? Yeah, nothing is perfect, especially in the world of technology. Every method or product has its pros and cons, and Toyota's solid-state battery is no exception. When we ask why such a promising battery is taking so long to reach the market, the answer becomes fairly obvious. Solid-state batteries aren't a brand new concept. They've been under research for years. That tells us that developing this type of battery doesn't just require significant R&D effort, but also faces serious challenges in mass production. According to Toyota, they claim their solid-state battery will cost 50% less to produce. But don't get it twisted. This doesn't mean it'll be 50% cheaper than current lithium-ion batteries. It just means it'll be 50% cheaper compared to Toyota's own original cost estimates for producing solid-state batteries. Still, the phrase "cut costs in half" has captured most of the public's attention. Traditionally, solid-state batteries have been extremely expensive to manufacture. That's largely due to the high cost of raw materials and the strict purity levels required during fabrication. For example, lithium sulfide, a potential material for solid-state batteries, can cost 5 to 10 times more than lithium carbonate. So yeah, the two main barriers holding solid-state batteries back are materials and manufacturing. Compared to conventional lithium-ion batteries, the components used in solid-state tech, like ceramic or glass electrolytes, are much harder to produce uniformly at industrial scale. They require highly controlled environments with near-zero humidity, specialized machinery, and advanced processing techniques that most factories today simply aren't equipped for. While the battery remains the most expensive component of an EV, every investment decision in new technology must be weighed carefully, especially when it comes to cost. And right now, the production cost of solid-state batteries is still significantly higher than that of lithium-ion batteries, not just because of materials, but also due to labor-intensive assembly processes that can't yet be fully automated. Another lesser-known obstacle is the issue of dendrites, tiny metal crystals that can grow through the electrolyte, potentially causing short circuits and reducing battery lifespan. Even though solid-state batteries are expected to be safer overall, the dendrite problem still exists. According to available research, scientists at Harvard University have developed a solid-state battery design using silicon that blocks dendrite formation, and their tests have shown up to 10,000 charge cycles, which is double the lifespan of today's lithium-ion batteries. Toyota is also pursuing similar approaches, so in the end, the biggest hurdles aren't in the idea, they're in the materials and the manufacturing process, both of which are still holding solid-state batteries back from mass adoption. However, once those barriers begin to fall, solid-state batteries won't just be an upgrade, they could reshape the entire EV industry, especially if bold claims from Toyota, like commercializing solid-state batteries by 2027, come true. It could be a game-changer. The edge in range, charging speed, and durability would dramatically favor early adopters in the battery tech race, and that would put real pressure on Tesla and other competitors to speed up their innovation or risk losing their lead in the next-generation battery era that's approaching fast. Elon Musk is increasingly betting Tesla's future on robotics, alongside artificial intelligence and autonomous vehicles, believing these will be the primary sources of revenue and profit for Tesla moving forward, as the traditional electric vehicle business faces growing challenges. In reality, Tesla's sales have sharply declined in major markets due to sluggish demand and consumer backlash against CEO Elon Musk's recent political activities. And as we've seen, Musk's relationship with Trump has erupted into a public war of words, adding further risks to Tesla's management front. Yeah, the company might face plenty of challenges ahead, but it's clear that the Optimus robot is still drawing significant attention and anticipation for most fans, partly because everyone wants a robot that can assist with daily tasks, while others are curious about what milestones Tesla is achieving with this humanoid robot. Recently, Tesla has been regularly updating on Optimus's development, with Elon Musk making even bolder claims about its extraordinary capabilities. However, we were quite surprised to learn that Milan Kovac, the technical director of Optimus, recently announced his departure from Tesla after over 9 years with the company. Kovac called it the most difficult decision of my life, explaining that he's been away from home for too long and needs to spend more time with his family abroad. To squash any doubts or speculation about other motives, Kovac made it clear that this is the sole reason for his exit and has nothing to do with anything else. His support for Elon Musk and the Tesla team remains rock solid. Kovac is also fully confident that those staying behind will take Optimus to new heights, alongside the broader Tesla AI, engineering, and production teams. He also made sure to thank Elon for teaching him many fundamental engineering principles. In response to Milan Kovac's farewell post, Elon Musk commented, "Milan, thank you for your outstanding contribution to Tesla over the past decade. It was an honor working with you. Enjoy the time with family." Honestly, we're pretty bummed to hear this, even though we support his decision. Thanks to Milan Kovac, we've gotten a clearer picture of the updates, tests, and technical achievements the Tesla team has made with Optimus over time. Milan always broke things down in a detailed, easy-to-understand way whenever Optimus had a new demo video. So, his departure leaves a big gap for Tesla bot fans and those of us looking forward to future updates. Getting back to Tesla bot, Optimus is getting smarter by the day, if not by the hour or minute. Tesla is still pouring tons of engineering effort into training and gathering data for Optimus as it nears production. The bot's killer feature is its learning through video ability. Yup, That's the ultimate tool for Tesla to speed up progress and scale up Optimus's tasks at lightning speed. 100 tasks a day? Not an exaggeration. Just turn on the TV, pull up YouTube, and show Optimus videos of cooking, using a vacuum, brewing coffee, or mowing the lawn. Boom. It picks up those skills crazy fast from those clips.
If Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
So you could say, pick up a cup, pick up a shirt, fold the shirt. These things will generalize, I think, quite quickly.
To make AI truly powerful and practical in the real world to help humans, Optimus is the ultimate machine with serious potential. You can ask AI how to fix a leaky pipe, and it'll guide you, but you still gotta do the work. Now picture that AI inside a robot that can think, move, and control its hands. It could fix the pipe for you. That's the real difference between plain AI and a humanoid robot. Right now, there's a global race, from China to North America, to build humanoid robots. But Tesla's Optimus is still the name stealing the show. Why? It's got the public's attention, and Tesla's big reputation backing it. Sure, there's plenty of skepticism too. Elon Musk's made some bold claims, and a lot of folks are wondering, can a company known for electric cars really pull off a humanoid robot? Elon says Optimus isn't following the same old playbook as other robots. Everything, from design to components, is built in-house by Tesla. The goal? Make the cheapest robot possible. He believes other companies flop because their production costs are through the roof. Tesla's got an edge by reusing parts from their electric vehicles like motors, actuators, batteries, and power electronics, giving them a huge leg up over competitors starting from scratch. Since taking the wheel at Tesla, Elon Musk has never played the same game as his rivals. He's always pushed for products that stand out and feel a bit weird, stuff you won't find at Ford, Rivian, Toyota, or anywhere else. And it's not just EV. Optimus is being built with that same vibe. What sets Tesla apart is how they're developing Optimus. Unlike competitors burning cash to make robots that can run, jump, or boast super smart AI, Elon says Tesla's taking a different road. More than half of their engineering team's effort is laser-focused on one thing: the hands. Musk has stressed time and again that Optimus's hands are a massive challenge, probably the biggest hurdle in the whole project. Unlike other parts, Elon Musk believes that nearly all of human intelligence is expressed through the hands. He emphasizes that over millions of years of evolution, no part of the human body has been more critical than the hands. From the earliest days of human cognition, our ancestors were able to build monumental structures and perform complex tasks without advanced thinking. That's why Elon Musk and Tesla have made the hands the engineering centerpiece of the Optimus robot. Musk is convinced that with these hands, Tesla bot will leap far ahead of competitors and become the most sophisticated humanoid robot in the world, capable of handling hundreds, even thousands, of tasks. A robot with a brilliant brain is useless without human-like hands. That's why Tesla bot is the first humanoid robot in the world with hands that have 22 degrees of freedom, just 5 shy of the 27 degrees of freedom in a human hand.
Yeah. The hand might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering.
But so much of the intelligence of humans goes into what we do with our hands.
Yeah.
You might not vibe with Elon Musk. You might think his claims are overhyped, but you can't deny that everything he bets on tends to pay off. Saying he became the world's richest guy just by luck and not business chops is straight up nonsense. And thinking he's dumping cash into Tesla bot just because he's got money to burn? That's dead wrong. Billionaires like him usually have a vision most of us can't even wrap our heads around. Sure, Tesla bot and Elon himself are just holding the lock. The key's with the customers. If Optimus isn't smart or useful enough to actually help people, that $20,000 price tag just buys you a fancy walking toy. Nobody's shelling out for that. But flip the script. If Tesla bot really has those game-changing hands and a brain that Musk boldly calls a true brain, outshining everything else out there, then it's a whole different ballgame. Once its usefulness starts turning into real money, people will be lining up to buy it. Think about it. You drop $30,000 on an Optimus, but then you never need to hire a shop clerk, tutor, or housekeeper again. Suddenly, Optimus isn't some pricey toy. It's a money printing machine. And yeah, if you're into making cash, you're gonna want one. When Elon Musk talks about Tesla Bot's true brain, he's hyping up a super smart processing system that can understand and react to the world around it, maybe even better than humans. Sounds wild? Picture this, you don't say a word. Just gesture or make a face. Point at the floor, it knows to mop. Rub your stomach, it brings you food. Guests show up, it's already prepping drinks. That's what Musk's getting at. A brain smart enough to read situations, scan the environment, and act. Not just automation, but awareness. In some ways, Optimus's brain works a lot like ours. Tesla's engineers say it needs to soak up data to get smarter, just like humans learn and gain experience over time. But unlike us, Optimus doesn't need decades of schooling. Our brains forget fast. Optimus locks in data from the first go. Take cooking as an easy example. You'd need to check a recipe and steps for a new dish multiple times because there's so much to remember. Optimus, it stores the whole process the first time and nails it on. Repeat without needing a refresher. That's exactly what makes Tesla Bot worth its weight in gold.
Probably not next year, but like in 2026, it's really the kind of thing where you could tell it to do kind of a wide range of tasks.
A lot of folks are wondering how Optimus will actually be useful in Tesla's factories. Sure, cleaning the factory or hauling stuff around isn't the main gig. Elon Musk made it clear on X. He stated, "The Tesla factory, especially our next-gen Cybercab line, is the product that, autonomy and Optimus are what matter." That's pretty much a straight-up confirmation of the tight link between Optimus and Cybercab. In fact, Musk has called Cybercab and Optimus a dynamic duo. One's a robot with 2 legs, the other's a robot with wheels. To put it simply, Musk says, this humanoid robot will be directly involved in building cybercabs. He said Optimus will initially be used in-house, potentially replacing 2 to 3 workers with high precision. This highlights Optimus's ability to streamline EV production, which could slash costs per vehicle significantly. While this year Optimus will mostly be working in Tesla's factories, Elon's long-term vision is to turn it into a household assistant. That's why in Tesla's demo videos, you see Optimus doing chores, cleaning, pouring water, picking up deliveries, watering plants. Musk believes if Optimus is truly useful, all 8 billion people on Earth will want one. Optimus can sort clothes by material or color, cook, or move smoothly over uneven surfaces. Still, it's not perfect, and Elon Musk owns up to that. The key is that the robot can learn from its mistakes and get better, just like humans. Right now, the number of tasks Optimus can handle is limited because it needs more data. Like us, the more it does, the better it gets, and it needs training and experience to level up. Let's be real. If robots get too smart, they could take some jobs. As we've said in previous episodes about the future of humanoid robots, Optimus will replace certain roles but also create new job opportunities. That's just the way it goes. More importantly, Elon Musk has been crystal clear. Optimus isn't some rogue robot straight out of I, Robot, or Terminator. It's designed to be a friendly, helpful assistant for everyday household tasks. Sure, you've probably seen Optimus wobble and thought it looked clumsy, but as we explained before, that's not a flaw. With a low center of gravity and advanced sensors, Optimus is built to stay balanced on rough terrain or in tight spaces. So Elon's pretty confident that Optimus's movement will eventually be impressive, hitting speeds of 5 miles per hour instead of the current 2 miles per hour. Of course, that'll take a ton of hardware upgrades. Optimus isn't just a helper for household chores, it's also set to bring some serious entertainment value. Elon Musk has spilled the beans that Tesla Bot will be able to play games using its real brain, potentially outshining humans thanks to its cutting-edge AI and the dexterity of its hands with 22 degrees of freedom. Optimus can grasp the mechanics of all sorts of games, from brainy puzzles to hardcore strategy titles. With its data-crunching skills, Optimus's AI mimics human-like awareness, letting it learn gameplay, cook up optimal strategies, react lightning fast, and make pinpoint decisions in real time. For example, it can watch pro gamers, pick up on their moves, teamwork, or long-term strategies, and then execute them with next-level precision. Its biggest flex? Analyzing videos and environments to make spot-on decisions, much like how Tesla's full self-driving tech scans maps and obstacles to navigate safely. And it doesn't stop there. The connection between Neuralink and Optimus is something we keep circling back to. As Elon Musk has hinted before,
or if someone has lost the use of speech, then they can still communicate to an Optimus. Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm or Optimus legs.
Clearly, Elon's statement opens up a groundbreaking vision of the fusion between humans and robots, aiming to overcome physical limitations and enhance human capabilities. For those who have lost the ability to communicate due to neurological injuries or illness, Neuralink could allow them to speak to Optimus using brain signals, creating a nonverbal communication channel that helps them reconnect with the world. Even more remarkably, the idea of attaching Optimus robotic limbs to people who have lost their arms or legs not only restores basic function, but could actually provide superhuman abilities, thanks to signal transmission from the brain to the robotic limb being faster than in a natural body. This showcases the potential of technology in restoring and even enhancing human biology. However, this vision also raises major ethical challenges. Questions about altering the nature of humanity, brain data privacy, and dependency on technology must be carefully examined. Furthermore, the cost of implementation could widen the accessibility gap between different social classes. To bring this vision to life, further research, testing, and multidimensional discussions are needed to ensure that the benefits outweigh the risks, while maintaining core human values throughout development. So in the end, we still need time to build trust. What do you think about this? Tesla has truly upgraded Optimus at an astonishing pace. 3 robot generations in just over 2 years. Optimus Gen 3 is expected to launch next year, once the current version's production line stabilizes. It will be the most advanced version available for purchase, and its price is likely to be significantly higher than previous versions. If the price reached $60,000 but it could handle every task you gave it, would you be willing to pay without hesitation? We think just interacting with the Tesla bot on a daily basis would already be something exciting. I mean, you don't have to be overly cautious or polite with it. You can simply tell it a story and see how it reacts. And it doesn't stop there. What if this robot could remind you to take your medication on time? Or remind you about upcoming appointments you often forget? It could also help the elderly get more comfortable with technology by providing simple, easy-to-follow instructions on how to use smart devices like phones and tablets. For children, Optimus could become an engaging learning tool, teaching basic skills through games and puzzles, helping them learn in a natural and interactive way.
I think humanoid robots will be the biggest product ever. The demand will be insatiable.
When the world's richest man places a massive bet on the Tesla bot humanoid robot and claims that Tesla could manufacture millions of units each year at a selling price of just $20,000, it's clear that profit is the first goal he's aiming for. But do you know just how massive that profit could be? According to Musk, it's enough to turn Tesla into a $25 trillion company. To understand how shocking that number is, consider this. Apple's current market value is around $2.9 trillion. That means if the Tesla bot reaches a $25 trillion valuation, it would be worth more than 8 times what Apple is today. The world is undergoing a major transformation, and AI is accelerating that shift far faster than most people expected. Even Tesla, once known primarily as the world's leading EV company, is no longer just a car maker. Step by step, it's becoming a true tech company with AI at the heart of its strategy. Just look at how Tesla expanded EVs. What started as a niche market in the US has now spread across Europe, Asia, and beyond. The plan for Optimus will likely follow a similar path, but this time, the pace will be even faster. Thanks to Tesla's expertise in large-scale manufacturing, advanced automation, and an integrated global supply chain, bringing Optimus to every corner of the world is no longer just a dream, it's entirely possible. Yes, Optimus holds a vast amount of untapped potential that we've only just begun to explore. So what do you think? If Tesla Bot proves to be truly useful, would you be willing to spend your money on one?